And maybe you could let us know about a specific method called the elbow method, which I had not heard about before, truly.
Okay. So indeed, yes, we basically do not skip, the concepts that are very important in the machine learning pipeline. This whole process from start to finish, where you first pre-process your data up to making predictions and then deploying your model. Each of the tools that are used during this process, we cover them and we explain them. And it's true that for unsupervised learning and especially clustering, we use the elbow method to figure out the optimal number of clusters. Because it's true that when you do unsupervised learning with clustering, not only you don't know what to predict, but also you don't know the optimal number of clusters that you want to identify. So if we take again this data set of customers in the mall, sure, you know that you want to identify clusters of customers, but you don't know how many. And there is an optimal number that will lead to great results. And the method, technique that will help you figure out this right number, this optimal number, is the elbow method. And why is it called the elbow method? Because it's actually a code that will plot a graph, the graph of a curve that looks like an elbow, and that optimal number of clusters will be found at the elbow. You just project the elbow onto the x-axis, because in the x-axis you have the different numbers of clusters that you experiment, and on the y-axis you have what we call the within cluster sum of squares. So the within cluster sum of squares is simply the sum of the squared distances between the observation points, meaning the customers, and the centroids of the clusters. So I'll give you a simple example. If for example we have 1,000 customers in the mall, and if we have 1,000 clusters, then the within cluster sum of squares will be 0, because each of the customer is the centroid itself. So the square distances is 0, and the sum is 0. However, if you have one cluster, then you have therefore one centroid, and you will have a huge number of the within cluster sum of squares, because you will have to non-null distances from each customer to the centroid. And so you see it's a curve that starts high, because when you have a low number of clusters, you have a big within cluster sum of squares number. And then it reduces as the number of clusters you experiment increases. And so at some point around in the middle of the curve, you have the elbow, and that's where you find the optimal number of clusters. And that's the elbow method, helping you figure this out.